All right. So again, now I'm just going to go ahead and go down here. All right. I'm assuming anything with algebra you're pretty good at. Is that pretty clear? And even if you're not, you didn't see the picture, you didn't understand the picture, you then can go to the explanations. The explanations kind of help you out. I don't think anything's difficult as far as the equations go. All right, hopefully I'm right. But if you had trouble with 1, 2, 3, or 4, you can still let me know. I'm just saying I think everybody here is smart enough to quickly look at that and figure that out. Mostly the concern is the what? The proofs, kind of, right? All right, so let's look at this. All right, so the first one I think number 5 I just kind of crossed out. I don't like the pictures and those kind of silly things. That's not ever going to be on the test. All right, sometimes when I write the homework, I try to look at all the problems that make sense, and sometimes I missed it. Number 5, like I said, I'm not happy with number 5. All right, but number 6 is nice. All right, number 6 is nice. Now again, I feel as if this is important because this is kind of like an introduction to what's going on later. All right, and does everybody agree? Kind of the proofs kind of repeat themselves a little bit. Do you agree with that? All right. Hopefully you kind of agree with that because I think that's true. All right. Does anybody have any questions with what we have to do on number 6, filling it in? All right. I feel like that's pretty good. All right. What about number 7? Was that okay, guys? That was kind of easy, right? Yes.
I only got 3 proofs on it.
Yes.
Felt like it was a month ago.
I'm asking you about number 7.
7?
This is what I'm asking about. Are you okay? I don't mind reviewing it. That's what I'm saying, guys. You want me?
Please review it.
All right, let's go. Let's look at number 7. All right. So what I'm going to do now is, does everybody agree 8, 9, and 10 is okay, right? Those are just the numbers, right? So here's what I want to do that might help me real quick to save me a little time. I'm just going to get rid of this. All right, and then I'll just write the proof in here. All right, so here we go. And again, the more you do, the better it'll get. All right. Now, of course, this is going to be the statements, and this is going to be the what? The reasons. All right, don't be lazy. All right. Now, it says here, given angle 4 is congruent to angle 7. Now, the most important thing I want to do is I want to write, when they're congruent, you mark them as congruent. Agree with that so far?
Mm-hmm.
And I think everybody gets one question right on the test because we get to say angle 4 is congruent to what? Angle 7, and that's given. All right? Make sense so far? Now, Emily, what is the relationship between 4 and 5? What are those called? Nope.
Oh, I think vertical.
Yeah, vertical, right? Supplementary would be the ones right next to each other, Emily. You okay with that or not? Now listen, don't again, you guys, I told one of my things this year is I want everybody to be comfortable with saying, hey, I don't understand something without someone else saying anything. All right? If I draw a question mark here, that question mark and 4 are supplementary. They form a linear pair. All right? Does that make sense? All right? So the ones that are directly across from each other, 4 is congruent to what? 5. All right? And 6 is congruent to what? 7. Do you agree with that? All right, so let's go ahead and write that. Number 2. We can say that angle 4 is congruent to angle 5, and we can say that angle 6 is congruent to angle 7. Now, who knows? That's called the vertical angle, and it's a theorem. The reason why it's a theorem is because we can prove it's true. All right, we can prove it's true. All right, is everybody okay with that? All right, now keep in mind, we're trying to prove that 5 is congruent to 6. Do you agree with that? All right. Now, was it really necessary to write both of those in there? It really wasn't necessary. Is there any harm with writing both of them in there?
No.
No harm. All right. No harm at all. All right. So now we're trying to relate, and here's what I try to tell kids when I'm doing a proof. I'm trying to relate 5 and 6. Do you agree with that? Right now, I have a relationship between 4 and 5. What do I want 4 to become?
6.
What do I want it to become, Charlotte?
7.
Why?
Because 7 is congruent to 6, and we want 4 to be congruent to 6.
Wait a minute. What are we trying to prove?
Oh, that's 5 is
We're trying to prove, right? We're trying to prove, and again, all I'm doing is I'm just pointing something out because I know it's hard. All right, that's what I'm trying to tell you. I know it's hard. I'm trying to show you how to reason a little better, right? I'm always keeping an eye on what I'm supposed to prove is true. Now, right here, I highlighted this for a reason. What part of the proof is in that statement right there? What part of the proof is in that statement?
5.
That is exactly correct. I have angle 5. Does everybody agree with that? You understand what I'm saying? Come on now. I have angle 5. I want angle 5 to be congruent to angle what? 6. So I need to change, and this is what I'm trying to make sure that you guys understand. I'm trying to change that 4 to a what?
6.
I'm trying to change the 4 to a what?
6.
I'm trying to change the 4 to a 6. Do you agree?
Yes.
All right? That's what I'm ultimately trying to do. All right? Does everybody agree with that? So tell me what?
Okay, so it says up top that 4 is congruent to angle 7.
Right?
So you can replace angle 4 with angle 7.
Yes, we can. Right? So let's do that. Number 3. Uh-oh. We can say that angle 7 is congruent to angle 5. And that's called a what?
Substitution.
That's called a substitution. And now what can I do?
And then you can, because it says up top, right above, it says angle 6 is congruent to angle 7. So you can replace angle 7 with angle 6.
That's correct. Angle 6 is congruent to angle 5. And we could call that a what?
Substitution.
We call that a substitution. Now, does anybody else think of something a little bit quicker than that? There's kind of a rule called the what?
Well, I thought it was quicker. I just went from like angle 4 is congruent to angle 5, and angle 6 is congruent to angle 7 to angle 5 is congruent to angle 7. Because can't you like replace it like quicker? Angle 6.
But what are you changing 5 to?
I'm changing 5 to.
So what I'm trying to get you to realize, guys, is we could, which we haven't discussed that much, but it is a property. It's called the transitive property. You guys know that? If A is equal to B, let's do this. If A is equal to B and B is equal to C, then what has to be true?
A equals C.
A equals C. So right now we're saying that, watch me, angle 4 is congruent to angle 5, and angle 5 is congruent to angle what? 7. Therefore,
4 is
oh wait a minute, that wasn't good. That's not what I wanted. Because it's not straight across. 4 is to 5. 5 is to 6. Oh, and 6 is to 7. Everybody see that? 4 is to 5. And then 5 is congruent to 6. No, it just doesn't flow the right way. All right, I was thinking the transitive property would work out a little better, but it doesn't flow one to the other. I thought it did, but it is not. Okay, Emily, how's that? Does that look good?
Yes.
You can see the substitutions, right? Okay, so now somebody else want to, 11, 12, 13, those are more numbers, correct? Are we okay with that? Yes. 12, you want me to show you? All right, so let's look at 12. So these are called what type of angles? 3 and 4 again are called vertical angles. And vertical angles are always congruent, right? And if they're congruent, their measures are equal. So we would just say 2x plus 23 equals 5x minus 112. Do you agree with that now? And then we would say, what is that? 3x is equal to, what is that? 135, is that right? And so x is equal to 45. All right. Now it says find the measure of each numbered angle. So that just solved for x, right? So then we just have to plug in. All right, we plug 45 in. 45 times 2 is 90. So I think the angles are 113 degrees.
Yeah.
Is that good? Yeah.
Can you do a 13? I kept trying to do that solve for x, but I kept getting like different.
All right, let's see. So I would automatically look at 6 and 7, right? And 6 and 7 are supplementary. So they add up to 180, right? So 3x and 2x is 5x minus 55. Is that right? Equals 180? You agree with that? Now to me, it'd be better to divide by 5 here. Everybody see that? All right, I'm trying to show you that. So x minus 11 equals 36. Is that right? So x is equal to what? So x is equal to 47, right? So if x is 47, then angle 6 would be 47 times 2, which is 94, which would be 73. And then we could say that angle 8 is equal to angle 6, which is equal to 73, right? And then we would say that angle 7 would have to be, and those are degrees, 107. Yes?
How did you get 11x minus 1?
I divided by 5, kiddo.
Oh,
You see what I mean? What I did, instead, normally I say plus 55, right? But to make it easier, I can divide everything by 5.
Oh, okay, I see now.
You with me?
So angle 8 equals angle 6, and angle 6 is
Yes.
73, and then, okay.
Yep.
That's, I couldn't find angle 8.
We're good now. All right. Now, which ones did I have you do here? Is everybody okay with 14 and 15? Is everybody okay with that?
I needed help with
14. Okay, so let's take a look at this. Now, I kind of, I think this is just saying if ABC is a right angle. All right, let's talk about that real quick. So that's given. All right, I don't think this is going to be too tricky, but let's see. Statements and reasons. It says that angle ABC is a right angle, and that's given. So far, so good, right? And then I think we have to say that angle ABC is equal to 90 degrees. And that, I think, is the definition of a right angle. Is everybody happy with that so far, right?
Mm-hmm.
Then, Emily, is that okay?
Yeah, I got that.
All right. So now 3, I think it's best to say that angle ABC is equal to, now I'm kind of squishing it. I don't like to do it. So let me slide this over here a little bit. So the measure of angle ABC is equal to angle ABD plus angle DBC. And that's the angle addition postulate. You happy with that?
Where's the second D?
Oh, that's my fault. That's my fault. Thank you. It's DBC. Sorry, that's my fault. DBC. Thank you.